Hi, and welcome back to the Azure SQL Bootcamp. This is day 3 of 4 of our bootcamp, and we're so glad to have you back or have you joining us for the first time. My name is Anna Hoffman, and I'm a data and applied scientist on the Azure SQL team. And I'm also joined by Bob Ward, a principal architect on the Azure data team. We're pretty excited to be here, right, Bob?
Yeah, Anna, thanks. It's kind of amazing. It's day 3 already. It seems like it's really flown fast for the first 2 days. Anna, we really delivered some amazing content, in my opinion, if you're out there wanting to learn about Azure SQL. Day 1, it was all about what is Azure SQL, kind of fun facts about how it's evolved, trying to describe, people understand what do we mean about a managed instance and a database. We've done deployment, configuration. Yesterday, deep dive, no fluff, right? Yesterday, deep dive into security.
Hyper-focused.
Hyper-focusedness, that became some term I found on the internet yesterday. So, security and performance, very, very important concepts for anybody wanting to get started in Azure SQL, especially people that are used to SQL Server. So yeah, it's been a lot of fun to be part of this so far.
Yeah, I definitely agree with that, Bob. And, in addition to what we've been doing in the mornings or evenings or whatever time it is where you are watching this, we've also had links to lots of other resources, whether it's on GitHub or Microsoft Learn with that free Azure sandbox that you can use and actually try all the demos that we've been showing you, and even then some. And we've got some more coming today as we turn to look at availability. And I also have some fun things planned for the end of this module, some that you might even not be aware are happening soon.
Uh-oh. There's no telling what Anna's going to come up with today that she hasn't told me.
I wanted to keep it fun and
Yeah.
interesting, so we'll see how it goes. Today, similar to other days, we will have a short break. We're going to try to do that at the top of the hour, give you about 5 minutes to get something to eat, get something to drink, and then come back with us to see some more of what we're talking about. Now, before we get into the content, I wanted to just give an overview of what we're doing with Microsoft Learn and Learn Live. If you haven't been joining us for the previous days, you can access all the recordings. There's a link in the chat for that, I believe. And once you join, what you'll notice is on the left side, or sorry, on the right side of your screen, I think that would be over here, or below your video screen, there are chat windows where you can actually chat with other viewers, as well as get your questions answered from members of our team. We've got great moderators on there for the 3rd day in a row. We're really grateful for them answering all your questions to the best of their ability, and also kind of surfacing some of those questions up to us. I also wanted to give a shout out to the Learn Live team, especially Rob Gibbons, who's running all of this for us in the back end, making it all possible. Making us look good and not cut off and all that good stuff. So thank you, Rob. And the other thing I wanted to mention is there are hands-on labs associated with what we're doing today that you can access today, tomorrow, next month, whenever you want. So definitely check those out. They're free. It's also on GitHub, and all the code we put on GitHub is free for you to use, including the slides are on GitHub as well. So you can come back to this or use it with your colleagues or customers or that sort of thing later. Okay, so all that out of the way, we can get started and talk about availability. This is something Bob and I talk about of being like one of the really great value adds for Azure SQL and just moving to Azure in general. And then we're also going to talk about some real world scenarios. We're going to put you to the test, and we're going to do a fun challenge and see how that goes. So without further ado, let's get into availability. We're going to cover a lot of topics that you find probably very familiar from your experience, from HADR to where did my backups go, how do I do point-in-time restore, some availability and consistency requirements and things that we do on our end, as well as how to monitor all this once you get it set up.
Anna, as we looked at security and performance, we kind of, if you see this slide right here, it's kind of maybe familiar to those that attended yesterday. We always want to look at what those capabilities are. What are the capabilities for availability for you in your deployment of Azure SQL? And then what are the tasks? What things do you go through using these capabilities to set up your solution to make it as highly available as possible? And you just think right out of the gate, you need to know about backup restore for disaster recovery and about availability to keep things going all the time in case there are problems. And so today I think you're going to find the story we're going to show you about those two topics are quite amazing. And to me, worth the weight in gold, perhaps, for moving to Azure. But we're also going to tell you how to go further with something called availability zones, geo replication, failover groups. And then we'll do some core SQL stuff near the end. We'll talk about just database availability, how we run recovery, those kind of type scenarios, and database consistency. But let me give a shout out first to SQL Server replication. We won't go into the details of that today, but you should know that SQL Server replication is fully available in a managed instance. You can set up a transactional replication system across your managed instances. And even people don't realize that you can set up an Azure SQL database as a subscriber to a publication. That could be on premises, that could be from managed instance. And in fact, that might be an interesting scenario for an online migration type problem where you want to use replication and make your Azure database as a subscriber. And then again, you have these tasks. You want to go and figure out, based on those capabilities, how do I pick the right deployment option for my RTO and RPO needs and my availability needs? How do I configure HADR? And how do I monitor availability? I always want to throw an in about monitoring because people want to know all the time. We showed you how to monitor security. We showed you how to monitor performance, and we'll also talk about how to monitor availability near the end of the session today.
Awesome. Thanks, Bob. And the first thing we're going to talk about is backups. Now, this is something we commonly get asked about when people move to Azure. They say, okay, what's going on? You guys are managing my backups, but what does that mean? So just to lay it out, we do full database backups once a week with log backups every 5 to 10 minutes and differential backups every 12 hours. Now, these backup files are stored in Azure storage with RAGRS storage. So what that means is it's read access geo-redundant storage. So right off the bat, what this means is that you have the option to do a geo restore. Now you might be wondering, what does that mean? So what this means is if a whole region goes down, you already by default, without doing anything, have geo-redundant storage of your backups. So you can actually pick to restore in another region in the case that something really catastrophic happens. You can be sure that you'll be able to restore that data. Another thing that we have available for you is point-in-time restore. Now, if you recall, in SQL Server, in order to do a point-in-time restore, oftentimes you need full recovery mode enabled. And if you recall from previous modules of this bootcamp, we actually talked about how Azure SQL really only allows you to run in full recovery mode. And one of the reasons is for this point-in-time restore. Now, retention for point-in-time restore can range between 1 and 35 days. This depends on the service tier you select, as well as the deployment option, as well as your actual choice. By default, it's every 7 days, I believe. Now, if 35 days isn't enough for you, certain deployment options also have the ability for you to enable long-term retention, or LTR. And this is going to allow you to retain up to 5 years of backups. And this is really interesting because if you have LTR and you delete a database, not a logical server, not a managed instance, but if you delete a database or several databases maybe 5 years ago, and then something happens and you need to be able to restore that database, you can actually go in and do that with LTR technologies. We talked about Geo Restore, and I mentioned the backups of deleted databases. With managed instance, you can even do a manual copy only to blob storage for backup restore with managed instance. So that's an awesome capability too. We're really kind of trying to take the stress away from you and give you the security and the confidence that we're going to take care of your backups. Now, Bob, when you look at this and you've been working with SQL Server, I always make fun for just a little while, just a few years. What stands out and what's the significance of some of the things that we do here?
Thanks, Anna. I spent a lot of my career in support, and no one ever calls Microsoft support and says, hey, my backups are working and I can restore my databases successfully, so everything's great. It's always a call to say, I can't restore my backups. I can't find them, or I don't have them, or they're damaged, or there's a problem. Just consider the fact that when you deploy an Azure SQL database or a managed instance, you get automation that kicks in and you get redundancy built in. Remember, we talked about the fact that like even in general purpose, your database and log files are in local redundant storage. So you got multiple copies within the Azure storage infrastructure already. The backups are separate. They're in geo-redundant storage. So the probabilities of having like a damaged file from a backup go to almost nothing. And people try to configure that themselves in their own environment. That's a task and a lot of work. But declaratively getting to say, I'd like to, 10 years of backups and here's my schedule I'd like you to build on, or the fact that I accidentally deleted a database and I can just go click and get a new one and get it back from a restore, or that point in time restore is just available by putting in a date, time, and just doing it. I mean, this is pretty significant stuff. I should also call out for folks that like a little more control, Anna mentioned about copy-only backups with managed instance. You can restore those copies to another managed instance. And in addition, we do allow a native restore in managed instance from backups from on-premises SQL servers, which is part of actually a migration strategy you can use. So I think we give you backup restore options, but we also give you just amazing built-in backup restore capabilities that is pretty difficult for folks to set them up themselves and to rely on, because Microsoft's got their backing behind all of this.
Definitely. And one other thing I wanted to call out, because I do recall seeing something on the chat about it yesterday. When we talk about point-in-time restore, something that's different maybe than what you would do on premises is that in Azure SQL, you can't restore on top of your existing database. And we really do this to protect you. What you have to do is restore to a new database name, and then you can go through and determine if whatever it is you were trying to fix or go back to is still there. And once you're comfortable with that, you can go ahead and rename your old database and then rename your new database to your current database. So you only have a minimal amount of downtime and you don't actually have to change any connection strings. And this is an example that you'll actually get to do hands-on if you go through the Microsoft Learn labs. We have a point-in-time restore lab for that. The other thing I wanted to ask you about, Bob, is we do backup integrity checks as a team. Can you share a little bit about what we do in those?
It's pretty interesting. We're going to use checksum as part of a backup option, which is a native part of SQL Server that's been around for a while. So you're able to see very quickly whether there's a problem with the media of the backup, putting the backup file itself. But we do restores for you. We automate process to randomly look at and do restores and do testing of restores, because sometimes that's the only way could something be restored. So we're automating things in the background to check and make sure that what we have available for you in terms of backups can be restored for you. So it's quite amazing behind the scenes, the automation, even from an integrity check point of view, we're doing for you.
Awesome. Yeah, I think it's a great story, and I'm looking forward to hear what you guys say when you try out these labs or even in the comments related to this. Now that we've kind of talked about backup and restore, we wanted to shift to talking about other things that are built in related to HADR. And we thought, what better way than to kind of dive deep into each of the service tiers for vCore model and look at the architectures. And then you'll kind of see what availability models we have set up from the get-go. And the first service tier we're going to talk about is general purpose high availability. So let's kind of walk through what you see on the right hand of your screen to get set up. So what we have is we have an application, and we have some gateways, and we have a primary replica. Now, if you recall from an earlier module, we talked about setting up connectivity from your application and how, there are really two options. You can go straight to the gateway every time, which will then point you to the database, or you can go to the gateway, then get the connection information for the database and go directly to the database. Those are called proxy versus redirect. So that's what you're seeing there is we have our gateways in a control ring. Your application is going to go there, figure out where the database is, and then get pointed to that. And that's really across all service tiers. But when we start to look at general purpose, what you'll notice is on the primary replica, on the locally attached SSDs, we have the TempDB. Now, the data and log files are actually stored in Azure Premium Storage, which is locally redundant storage. And your backup files, as we mentioned for backup restore, are stored in Azure Standard Storage, which does have that geo redundant storage. Now, when you think about this, you can think it kind of behaves like a failover cluster instance. And if you want to think about what would happen in the case a failover would need to occur, you might want to first back up and say, why would a failover occur, or what would trigger this? Now, recall back way at the beginning, Bob talked about how really Azure is kind of built on this Azure Service Fabric backbone. Now, if the service fabric detects something is wrong, what it's going to do is it's going to try to initiate a failover. And just like a failover cluster instance, it's going to first look for a node with spare capacity, move the database file, and run recovery. So this can take some time depending on the capacity and how close it is that is moving. But then we'll repoint everything for you. So again, as long as you're going to the gateway and then the database, you're going to be redirected automatically, meaning you can fail over. It only takes, less than 30 seconds, and then you're back up and running. And what I want to really stress here is that you didn't have to set anything up for this. All you did was deploy a general purpose database, and you just get this right out the back for managed instance or single database.
Yeah, Anna, so you're exactly right. General purpose just feels to me like a failover cluster instance. Shared storage, right? Temp DB on your local storage. But what about business critical? Because we talked about the fact that business critical has some interesting properties. And we even mentioned to you about faster recovery times from failover type problems. So how do we achieve that? So you see in this diagram here, it looks pretty much like what Anna just showed you, except notice one difference here. The primary replica, still we have the gateways, right? The primary replica has the data and log files on the local drive. TempDB is also there, by the way, separately. We don't show that, but it's always there. But notice the data and log are on the local drive now, not in Azure storage. So in order to achieve now high availability, we're gonna actually deploy an availability group for you behind the scenes with multiple secondary replicas where data and log are on local storage, just like you would do in an always-on availability group scenario. What's interesting about this is that we always try to keep 4 replicas available at all times, 1 primary and 3 secondaries. And if you kind of look and think about this and think about availability groups, how are things synchronized? So what we do here is that your transactions on the primary are allowed to commit as long as one of these secondaries can acknowledge they've hardened your log, just like a synchronous availability group scenario in your environment. So as long as one has acknowledged I've hardened the log change, we can go through and let the commit proceed on the primary. So it's got that feel of availability group, right? You're still connecting into the gateway though, so you're kind of abstracted from where you're going. And as Anna just described a second ago, what if a failover occurs in this environment? So we're still using the service fabric logic, just like we did with general purpose. The service fabric, for example, is monitoring is the rack down or host have a problem or the overall virtual machine. But SQL Server integrates with that, what we've developed in Azure SQL, both for general purpose and business critical. So we can detect with service fabric, or we can help signal to service fabric, we should initiate a failover. So what if a failover occurs? Well, in general purpose, Anna talked about you'd spin up another node, like spin up another SQL Server and just point to your database and files on storage. But remember, we have a replica design. So we're going to fail over to a replica that is synchronized, right, where the data and log files exist. Now, the backup files are still in geo redundant storage, just like general purpose. So just like in your environment, you would store your backup files in a separate storage location. We do the same. We make it geo redundant. But the data log files, this is a non-shared storage solution, just like an availability group. Now, what's interesting about business critical is a couple things. Number one, for free, one of these secondary replicas you can use for read purposes, and you can use the same type of techniques to specify your intent for read only when you connect. But just like what Anna talked about, what I love about this is that there's no listener for you to just deploy. You simply use the gateways. The gateways are in charge of deciding what replica you go to, where is your primary, where is your secondary to be connected at this point. So again, it feels like an availability group because we're using that technology. But as Anna talked about general purpose, you just deploy business critical and you just get this. This is what we provide for you. And so you can see though in a failover scenario, since we're always redoing logs on your secondaries, we simply just have to run recovery using accelerated database recovery, which we'll talk about later. And so failover can be quite fast compared to general purpose. Now, Anna, I know we talked about this. We were building this training together, and I'm like, Anna, I have some thoughts for you how to build a demo. And you're like, Bob, I got this. Let me show you something. So maybe you should show the audience a pretty nifty demo how to compare failover times between these two options.
Yeah, definitely, Bob. And like the audience has heard, Bob taught me how to use OStress, and now you'll see it everywhere in all the things that I do. Let me just run a few things to get this set up, and then I will explain to you what is happening, because there is a lot going on here. So let's start by looking at the top part of your screen. So what I have up here is Azure Data Studio, and I have two PowerShell notebooks, one on the left and one on the right. And the one on the left, and really everything on the left side of this screen, is related to a general purpose database. So remember, similar to a failover cluster instance. Now, everything on the right side of my screen is related to a business critical database. And what I have running in the PowerShell windows below is a very simple command. So if we take a look at it, I'm using ostress, connecting to the server, just selecting the count from a table for the business critical database. So that's what you're seeing on the right, just the results of that. And similar on the left side of the screen, I'm running the exact same query on the same database content, but a different database, except this time on a general purpose database. So all you're seeing is the results from that query. Again, left general purpose, right business critical. Now, this is just supposed to simulate an application that has retry logic, which is very important, and we're just continually trying to basically connect to it. So what you can do is, while Service Fabric will do an automatic failover, you can actually use PowerShell to force a failover. Now, you can only do this once every 30 minutes, but what this allows you to do is kind of see how fast these failovers can be. So what I'm going to do is I'm going to try to click these buttons and run these commands to initiate a failover at the same time. And then I want you to observe what happens to our connectivity, remembering that right is business critical and left is general purpose. So I'm going to kick that off.
And it's like the dot race you see at the, at the ball game.
Yeah, exactly. So immediately what you see on the right side, as well as the left side shortly after, is that these databases become unavailable as the failover begins to occur. But what you've noticed is with business critical, it was very fast, almost immediately, maybe 3 to 6 seconds is how much I usually see this take. We have gotten reconnected. And the reason for this is because we are running on that availability group. So we just have to kind of switch pointers to a secondary, and we're almost up and ready to go. With general purpose, it was still less than 30 seconds, which is still pretty powerful for just deploying it and not configuring anything. But the reason it does take a little bit longer is because we don't have a secondary, on standby, ready to go. So that's kind of a fun demo that we like, and really powerful, really shows you what I've been calling the power of PaaS, or the power of platform as a service. So definitely something really interesting, and something you'll get to play with in the hands-on exercises as well. Now, Bob, this is actually pretty historic for us, because this is where the hashtag Anna that was awesome came from.
Yeah, that's actually a true funny story. We were filming one of our videos for the YouTube series, Azure SQL for Beginners. And I remember at the very end of this, because I remember giving you some pointers about how to kind of build this, and you went off and built this, right? And I don't know if I'd seen the full demo until we had recorded the video, and I was like, oh my gosh, that is awesome. So they caught it at the end of the YouTube video. So yes, I think that has become my new hashtag, just like hyper-focusedness.
Hyper-focusedness,
right?
yeah.
I can even say it. So.
And, Bob, while we have a second, Anthony asks a great question. He says, if business critical has availability groups in the background, when or why would I ever do my own availability groups?
Yeah, great question, Anthony. That's really what platform as a service is all about, Anthony. So we are going to deploy an availability group for you with, say, Azure SQL Database or managed instance with this business critical option, and you don't have the option of doing your own availability group. And you're even going to see later in our session today, we're going to support something that feels like a distributed availability group. So it's our belief that from a PaaS perspective, we're kind of removed the need for you to ever have to do this. Perhaps there's some sort of nuance about an availability group that you want. Maybe you need more replicas that we can provide, but just wait, because we're going to show you how to do multiple replicas. So that when you'd go to something like Azure Virtual Machine and do your own configuration. But we've found what we've provided in the business critical and what we're going to show you in Hyperscale, or things like auto failover groups, that we have a lot of that functionality that you probably need, including read capabilities, those kind of type things with our built-in deployment. So we kind of think you don't need to do that if you choose platform as a service.
Thanks, Bob. But also thanks, Anthony. I think it's a great call out. And again, a great
Absolutely.
reason to consider a PaaS service. Now, the last service tier, which we haven't really talked about yet and is only available in Azure SQL Database today, is the Hyperscale tier.
You know, Anna, as we've evolved Azure SQL over the years, we showed you that history at the beginning of, like, we did managed instance, cloud lifter. And we did that for the purposes of ensuring that we could provide a bigger surface area for instance level features. Well, customers came to us and said, we need really large databases for the cloud, and you need to find a way to make that work. And so we're thinking to ourselves, how do we create a scalable solution that's high performant and allows for this large amounts of storage of databases and provide some interesting characteristics? And so a project was developed called Socrates that led to something called Hyperscale. And this is only today available for an Azure SQL database. And its unique architecture, today at least, is one you need to think about carefully. Because if you go to this architecture, you deploy Hyperscale, you can't move back to a different one without migration. So it all starts with primary compute or primary nodes. And on this is a SQL server. And your primary is where you're going to do your read-write operations. And what we're going to do a little bit different here, though, is we're going to have a cache, a local SSD cache, a little bit like buffer pool extension, but slightly different. So you have a buffer pool in your SQL server, but if you can't fit it in there, we're going to try to put it in this cache, which is a local SSD drive. So if you try to go read from data, we'll go to the buffer pool. If not, we'll try to go to this cache. So that's like one layer of this model. I'll talk about secondaries in a second. So another possible layer, though, is something called page servers. So another set of SQL servers, also with caching, buffer pools and caching. And so if we can't fit pages there, we'll go to these page servers, right? And we actually have redundancy built into these servers, and they're paired together. So we have that all figured out as well. So you see this model right now. You're asking yourself, where are my database files? So the third layer is where we keep your database files. And we actually use Azure Standard Storage here. This is where we're going to keep your database files, which is going to allow us to do something very interesting. We're going to be able to use snapshot backups because you're primarily getting your data from the upper layers of this distributed caching system. So we can afford to be able to do a snapshot backup, and a restore actually uses a snapshot backup. And Anna, this is where restoring of terabytes, multi-terabytes of data can happen in a very, very short time frame. So it's pretty amazing technology. So you're looking at this model, and you're like, okay, I kind of get it. I see how you're doing multiple layers of caching of pages and so forth, that kind of type thing. What about the transaction log? How do you do logging here? Well, as it turns out, what we do is, in the primary compute, wherever doing your read-write, when you need to flush log records, we still have the standard log manager in SQL Server. We're going to redirect those flushes to something called a log service, which is on a separate node running. It's redundant as well. And we're going to use its own caching mechanisms and something called a landing zone with Azure Premium Storage. And then, as necessary, long-term log storage for point-in-time restore capabilities is in Azure Standard Storage. You see how we've separated things here in this model. And by the way, those snapshots are in separate storage as well. We've provided a very redundant solution here. Now, let's talk about those secondaries. Like, how does that work? We don't necessarily use availability group specifically here, but we use the concept of log change technology from the log service to feed secondary replicas and to feed the page servers. So as we make changes, those page servers are going to get up to date because we know in the transaction log how to do that. And then we know how to keep these secondaries up to date because we're using the log service. It's a pretty amazing system. The auto failover capabilities, though, Anna, are the same. We're still using Service Fabric. We're still using SQL Server to decide, do we need to fail over, though, from a primary? And Anna, you asked me at one point in this architecture, because I was building the slide, and it used to say 1 to 4 secondary replicas. And I said, actually, that's not true. It's 0 to 4. I think you asked me that, right?
Oh yeah. How would I have 0?
Yeah, how can you have availability with 0 replicas? You should think of Hyperscale as a combination of what we've done with general purpose and business critical. So imagine this diagram and you had no secondary computes. You just had the primary. Remember now, the data files though are not, they're a shared storage. They're on the actual Azure storage. So if you needed to fail over with 0 replicas, we would spin up another compute. We would be able to refresh the data from our caches and our data in the actual Azure storage, and we'd be up and running with our primary at that point, right? Now the failover time is going to be longer because it's kind of like a GP scenario where we got to bring up a SQL server, and in this case we got to feed it. We got to feed SQL in these cache scenarios. So you can do 0 if you want, but here's the cool story. You can do up to 4 secondary replicas, and they all can be read replicas. So now, in the case of BC, we only had 1 read replica. We can give you 4 of these, and all these secondaries are fed again from changes in the log. So in those cases, Anna, your recovery time or failover time is going to be much faster because now it feels like a business critical because those are being fed from changes from the log service. Pretty amazing architecture.
Yeah, definitely. And, it continues to amaze me how we really re-architected SQL for the cloud. Another funny thing I wanted to call out before we get into the knowledge check is as we were going through this, I asked you, Bob, about your typo of SQLserver.exe.
So Anna was really showing her age here, or lack of age. So this is not true story. We were filming this video, and I think I don't know if it was live or was in a side question. She goes, "Hey Bob, they made a typo in this diagram. SQLserver.exe is missing the E before the R." I said, "Oh Anna, you sweet young person." SQL Server exe, if you notice, it's 8.3, which is the file naming convention for DOS and OS2 back in the day. And so we had to use 8.3 for SQL Server. We just cut off the E. And by the way, Anna, I don't think that'll ever change. I can't even imagine the product, what would happen if we tried to go in and change this to be like, greater than 8.3. It probably would break the entire product of SQL. But there's your story of the legacy of SQL Server in 1993 running on OS2. Yeah.
I love it. SQL Server exe. Now we have a knowledge check, but before we get into the knowledge check, I'm going to ask a question from David O'Keefe. He asked, what is the downtime associated with moving from standard to business critical? And then the second part of that is, what about moving between generations of compute or hardware, i.e. Gen 4 to Gen 5?
Yeah, thanks, David, for that question. So moving from standard to business critical is kind of like a scaling operation in a way, correct? And same thing between hardware generations. So if you think about GP, we've got things on Azure Standard Storage, and if you go to business critical, we need to go set up those replica systems, right? So we have seeding involved. So the larger the databases are, the longer that operation could potentially take. But be aware of this. One thing, we're pretty smart about this. So when we're setting things up, it's not like you go change to business critical and immediately you're just down. We wait and we let you run to the longest possible moment. We have to switch over and put you in involved. And again, you're just using the gateways, which is beautiful about from an application point of view. But you can expect there's going to be a longer downtime than, say, scaling from 2 to 8 CPUs in general purpose, as we've shown you in that operation, because we got to see those replica designs. Same thing between like Gen 4 to Gen 5. If you're doing that in GP, that could take longer depending on us trying to find a node that has a Gen 5 type processor, right? But in the GP case, we just have to go find a new node and point to the database files that exist. So that switch within, like, say, a general purpose service tier can be much faster. Does that, Anna, you kind of agree with that?
Yeah, definitely. I think that's correct. Now, a lot of people have already started to answer these questions, but just to kind of read them out and then we can go ahead and start talking about them. The first question is, which service tier puts the data and log files on Azure Premium Storage? And the second question is, which service tier has an always-on availability group behind the scenes? So if I take a look at some of the answers we get in.
Yeah, let's take this is it. You were a little tricky on this one, actually. If you ask me, that first one, I think people need to really carefully read that sentence.
Yeah, and I think that shows in our answers. For the first question, I'm seeing D, A, C.
DAC. You're seeing you're seeing a mixture. Okay.
And B, we're seeing a good mix of all.
Okay. This is actually good. This is good.
This is good.
We're gonna solve the mystery. Yeah.
It looks like a lot of B's are starting to come through.
What about the second question? What are you seeing on that one?
The second question is, the majority of folks are saying B. A few people have said C and D, but most people are saying B. I would say there's much more consensus on the second question.
Okay. You want to let them keep coming through, or you want to tackle them?
No, why don't you go ahead and tell us?
Well, if you remember yesterday, we used the Sherlock Holmes method, right? We did an elimination process to answer our questions. And I just encourage anybody. I love answering questions. I think that's the right way to go after things. I taught my boys that, how to take tests that way, right? So anyways, in the first one, which service tier, okay, this is a good thing. These three choices are service tiers. I'm glad everybody is probably resonating with that. Puts the data and log files on Azure Premium Storage. So first of all, it can't be B, because business critical, if you remember in our diagram, puts data and log files on local SSD storage. So let's X that out, which means we can X out D, right? So it now comes between A and C. And if you remember very carefully in that last diagram, we actually put your data files, the data files, on Azure Standard Storage, and the long-term log files on Azure Standard Storage, right? Because we're trying to make that as cost-effective as possible to deploy your solution. So if I thought about that, the data and log files together, the only solution that lines up for this is general purpose. So that should be A, I think. Yep, there you go. Okay, let's talk about the second one. So which service tier has an always-on availability group deployed behind the scenes? So it can't be A, Anna, because if you remember correctly, and you look at the comment to the left here, if you put your files on Azure Premium Storage, all of a sudden now you're using a shared storage solution, not a replica-based solution. So it can't be A, therefore it can't be D. So if I look at this carefully, I got B and C now. Now I just mentioned that Hyperscale uses a logged-based approach to ship changes, to these tiers. But if you remember correctly, I said it doesn't use an availability group specifically to make that work. So I think the answer's got to be B. There we go.
Awesome.
What do you know?
Great. So I think most people got number 2. I think we tripped some people up on number 1, but it gave us a great opportunity to take a look and dive a little bit deeper. Looks like we have a question on the screen from Duke Newcomb, who asked, do you really work with Buck Woody?
Oh my gosh. I'm supposed to answer that and not laugh out loud? Unfortunately, yes. I do work with Buck. Actually, to be complete serious, Buck is one of the super coolest people on earth. But I will just make one funny story for you, and I'll let you comment, that we will be when we used to travel together, we were at dinner, and we would call out something, and then Buck tried to describe the history behind something, like where it came from. And my comment was, here we go. Because here's going Buck again, right? So we all laughed together and used that comment. Here we go. So I don't know, Anna, about how you want to say, but love working with Buck. I know he's moderating us today, but Definitely. Yeah, we do work with Buck.
Yeah, and we're very grateful for his work. I know he's very active on the chat answering y'all's questions. So awesome. Now we are going to continue talking about availability. And really, we've talked about the different service tiers. And you might be wondering, okay, how can I go to the next level? Or are there other ways I can go to the next level? And we're going to explore a few other ways you can kind of go further with availability. And the first thing we're going to talk about is zone redundant configuration. Now, you might have heard this phrase used. There's lots of different words that we use to kind of describe this. You'll hear like availability zones, you'll hear AZs or multi-AZ or zone redundant configuration. So they all mean the same thing, but we want to talk a little bit more about what it is. So this is free today in the business critical service tier. It's actually only available today in Azure SQL Database business critical tier. And it's really easy to set up. You just go in the portal and it's just like a switch you flip on or off. It is off by default, and we'll talk about why in just a few moments. But let's talk about this architecture you're seeing on the right-hand side of your screen of what this means. So what you're seeing is the business critical database, and this should look familiar, that always-on availability group, the way failovers occur, all the same. Your Azure Standard Storage for your backups. This is just business critical deployment. Now what's changed is you have these multiple AZs, so AZ1, AZ2, AZ3. Each one has its own gateway, and each one has at least one replica in it. So what does this mean? What this means is that in one region, we are going to spread your availability group across 3 availability zones, meaning an availability zone could be a different data center, but in the same region. So you're not going to have everything right on one machine in one region, in one data center. You're going to have it spread across multiple data centers. And this really helps you if there is something that happens in one data center in a region, you're still safe because you have a secondary replica, at least one in each of the other availability zones. So this is a really great benefit for availability. This is how we're actually going to be able to provide you the highest SLA, which we'll talk about after this, but the highest SLA is going to happen with zone redundant configuration, or what you'll hear, a multi-AZ deployment. Now let's talk about a few of the other things that you see. One thing that you see is now we have 3 control rings with gateways as opposed to just one. So how does this work? Are you going to have to set up Azure Traffic Manager? No. So what happens is we actually do all this work for you. So you just point your application to your database. We're going to go to Traffic Manager to figure out which availability zone to send you to, give you back the database that you need connection, so you can connect directly to the database depending on which method of connectivity you're using. So really, again, similar to business critical architecture and general purpose architecture, you don't have to really set this up at all. You don't have to worry about it. You just check the box and you're good to go. Now, one thing to be aware of, and one thing we get questions a lot about, is why isn't this on by default? Bob, you want to answer that question for our viewers?
Yeah, one issue here, just to let you know, is the fact that this is not available today in every single region, and because we need to be able to have the ability to have zone redundancy in a given region around the world. So there's other particular scenarios here where this is a little more difficult to create the zone redundancy across, say, like a hyperscale type deployment, right? So, and then for general purpose, remember we have Azure shared storage to figure out across these zones. So there's a few complexities we've got to figure out behind this, but the good news, Anna, I'm pretty confident here that you're going to see zone redundancy be a big part of what we do going forward with just about all the deployment options we offer.
Definitely. This is definitely true. So thanks, Bob. Bob, one other question I have is we say it could slow down latency sensitive OLTP applications. What does that mean?
Yeah. If you look at this diagram right here, you can kind of see why that might be the case, right? So remember we talked about in business critical that we have to have a commit, cannot be allowed to go forward unless one of the secondaries, at least one of them, has said, I've got you back. I've got your log hardened. So imagine that in this particular case, the secondary in AZ3, for example, is the one that has to come back to AZ1. Even though these are close, there's still network connectivity between these that is slower than just say in a single AZ. So because of networking between the AZs, for a secondary to come back and signal that I've hardened the log, it could be slightly longer. And it's really hard to say how longer that is. It just maybe longer than you're used to. But if, let's say you're using like an in-memory TP application where transaction logging can be the bottleneck, that's something you got to take account of in a situation like this. Yeah. And one thing we've been talking about so far with all these different architectures is the promise we're giving you about something. But where does the rubber meet the road? Like, what's the real promise? So if you're not aware, we have a service level agreement, or SLA, specifically for Azure SQL. And if you look at this diagram on the left-hand side, it usually deals with something called nines. Maybe you've heard that in the industry before, which talks about uptime and downtime expectations of your deployment. You may be in your data center today providing a solution to your internal customers with 9 promises, right? Well, we do that. And in our case, for our promises, these 9s deal with promises we make that deal with your subscription. So if we don't meet the SLA requirements for your application, you can apply for a credit towards the Azure account you're paying Microsoft for a subscription, which is pretty amazing, right? And if you look at this, there's a single zone SLA. This is dealing with cases where availability zones you're not using, the zone redundancy Anna just talked about. And notice here that you're going to get the same for GP and business critical in the single zone scenario from an SLA perspective. But hyperscale varies because remember I talked about if you have more than one replica or have replicas, we're going to make that availability better for you in the case of these 9s expectations. Notice in the multi-zone, right, since BC or premium as well is the only offering today, this is the highest SLA you have. And Anna, when we were building this together, I've heard this term in my career for a long period of time, but I have to admit to you, I never researched what that meant. Like, what does that even mean? Well, as it turns out, 99.995 is called 4.5 nines. And technically, in computer science terms, that translates to about 26 minutes of downtime a year. So if you go to that highest level of SLA, that's your expectations of how much uptime you're actually going to get across a calendar year period. Now, on the right-hand side, we talk about recovery point objectives and recovery time objectives. Now, this is really interesting because we are the only database cloud provider that offers SLAs on these concepts, not just being available, but having times for how long does it take to get back and how quick and how much data loss you might have. So if you look at this, for business critical tiers, and that's the only tier that we're going to offer this SLA, it's it's an amazing, right? Those are amazing stories in terms of the times we provide. But here's what's important. You have to use Geo Replication. You have to use other features of Azure to achieve these type of SLAs. And then I think it's important maybe that we talk about that. Like, how do you go further past what we've talked about into more of a distributed way of doing availability?
Yeah, definitely, Bob. I think it's a great call out and great lead in to talking about some of these ways you can kind of create a geo distributed type of application. And really, you have two options for this. You have geo replication, which Bob just mentioned, and you have auto failover groups. And we created this chart and kind of highlighted some stuff blue to signify what might be better in a certain scenario, but it's really going to depend on your scenario. So to call out a few things, a big difference between geo replication and auto failover groups, as the name might imply. With geo replication, you cannot do an automatic failover. You are going to have to failover manually yourself. And in addition to that, with geo replication, you actually need to update those connection strings after the failover occurs. Additionally, geo replication isn't available in managed instance today. So if you're running in managed instance, really your only option is to use auto failover groups. Another call out is that with geo replication, sometimes customers want to have multiple replicated servers or databases across the globe. You can do that with geo replication, but with auto failover groups, you really just get one auto failover group. And of course, both of these options support read scale. That's a big part of the purpose. And additionally, with geo replication, you can have a replica that's in the same region as the primary, which is not something you can do with auto failover groups. So kind of, a lot of differences to consider, but really we're just giving you this information so you can make the best decision as it applies to your scenario. And we kind of thought, let's dive a little bit deeper into the architectures here.
And I'm a visual person, so I love your table that you said, but I'm trying to put my head around why it's different. And actually, georeplication is where we kind of started with this concept. If you look at this diagram right here, you need to think in your mind of a distributed availability group in SQL Server, which uses sync replication within its own environment, along with async replication to another environment, right? Which is why Anna talked about the concept of failover. So in this particular case right here, you can see our primary logical server, and we have read-write traffic, and we'll talk about traffic manager and load balancer in a second, but pretty much think in terms of what we talked about deployments, where you're connecting to a logical server for read-write applications. You also can connect to read-only traffic, right, using this secondary concept. But remember, like even in a BC scenario, you can also have a secondary on your local logical server. So you have the secondary logical server. We're asynchronously sending changes to this secondary logical server. And in this particular case, if you failed over to this secondary logical server, again, it's a manual concept that Anna talked about where you be changing your connection strings. Then you have the same concept of having read write and read only, and you can have multiple of these, right? That's the concept here. You can have multiple secondary logical servers that you're going to point to in this environment. Now, you may be asking yourself, if it's async between these two servers, what about data loss? And that's fair. Because it is asynchronous, it is possible that's the case. But remember, this is a manual decision that you're making. So you have the ability, by the way, through a system stored procedure to force this to be synchronized before you make that manual failover decision. So you do have that in mind. So that's kind of georeplication available today with Azure SQL Database. Remember, managed instance does not offer this option. Okay, what about an auto failover group? As the name implies, this is automatic failover, and this is the only option you have today for managed instance. You can do this with Azure Database, though. Now, in this particular case, we're going to use the Geo Replication Architecture behind the scenes to implement this with some differences. And you kind of see some of them here. Notice in the case of the primary logical server, there can be multiple databases as part of this failover group. Kind of feels like an always on availability group in that case, right? We're still using a distributed asynchronous operation to go to this secondary logical server. But also notice in the middle here some things called listeners. And in fact, if you kind of compare these side by side, you can kind of see some of the differences. Multiple databases allowed on your primary for an auto failover group. Again, auto failover being part of the promise here. And then you have these listener concepts. And if you've used availability groups, you know what a listener is. It's an abstraction layer, right? So that's why Anna said that for an auto failover group, you don't change your connection strings because you just point to your failover group server from read-write purposes or your failover group server with read intent, and you get directed to the appropriate primary or secondary read scenarios. So this is kind of the difference. Now it is auto failover. So a little bit architecturally, again, hyper-focused, Anna, right? I'm going to give you the details here. So if we detect an automatic failover needs to happen and there is no data loss, we'll just fail you over. If we think there might be data loss, we have what's called a grace period, which is defined by default as an hour. You can up that to 24 hours if you want to. And that's the time we'll wait to make sure things are synchronized for that auto failover technology to take place. In addition, in auto failover, you can implement that system store procedure I talked about within your application. So in a way, you could force synchronization to occur as you commit each transaction if you wanted to make sure that there was zero data loss occurring here. So pretty cool. And let's just also mention at the top here, Azure Traffic Manager and load balancers. You could deploy that yourself. We don't do that automatically. And again, I'm not talking about the zone redundancy thing that we talked about for traffic management. That is done automatically. But you could put a traffic manager on top of these scenarios, and they could be used to do load balancing and point to the appropriate servers, whether you're using the listener or not using listener. So we have some documentation how you would design that from an application point of view to kind of give your web apps the ultimate resiliency along with this scenario. Because maybe you want your web apps to fail over correct along with your database deployment. You want that to be synchronized. And that's where traffic manager and load balancing would come into play. So, Anna, the really cool architectures, again, if you think about what we've talked about, we're using the power of what we've built in SQL Server with things like availability groups and with things like distributed availability groups behind the scenes, but integrating that into the Azure ecosystem.
Yeah, thanks, Bob. I like the hyper-focusedness. Not even really sure how to pronounce that.
I don't either.
We have a question from the audience.
Sure.
Colby asks, do you also have a switch which pins the database to a selected data center or country? I'm not exactly sure what they're asking here, but Bob, maybe you have some ideas.
Well, if you remember, when you deploy Azure SQL, let's just talk about not doing geo replication. You decide where that's going to be. So you pick in terms of a region, and then that region defines country in many cases, right? Or a data center. So it's up to you to decide, where does that database reside? And you could have multiple databases in different regions. You could use this scenario here with geo replication and failover groups. Again, in the case of geo, the secondaries could be in your same region or in different regions. And then you could have your app, like from a read-only point of view, pointing to a specific region. So as far as pinning it go, that probably sounds like more of an application design thing you'd be doing where you know where the regions are of where you're deployed things. So for example, you may have a primary in the United States in a particular region, and that's where you want your app pointed to, but you want specific customers that are read-only to only look at data that's been replicated in Europe. So your app would have to know to go to that read server based on the logical server name for that region or country. That's kind of my thought about it, Anna.
Awesome. Thanks, Bob. Another thing that might be interesting to folks is if we take a look. So let me get this back up in my virtual machine. Give me one moment to just resituate all these windows, and we'll take a look. Let's see. Again, all these labs that you see are going to be available for you. Let me just make sure we're connected, get this running, and then I will explain. Okay, so while this is running, let me explain what you're seeing on the screen. So on the left side of your screen, again, similar to the previous demo I did, I'm using Azure Data Studio, specifically the PowerShell notebook. Big fan of these. You'll see me use these a lot. And in the Microsoft Learning path, you'll actually have a choice to use a notebook or use something like the Azure command line interface. So you can kind of pick whichever one you want to use. And what we're doing here is I basically have this notebook on how to set up a failover group. Now, I'm not going to go through the process, but what you can tell is at step 7, I'm ready to initiate a failover. So what that means is with less than 6 commands, PowerShell commands, I'm able to deploy another server, deploy an auto failover group, get everything set up, get all the networking set up in 6 commands, which is pretty crazy because if you think about the logistics that would go into actually doing this on your own without Azure, I think it would take a little bit more than 6 PowerShell commands. So that's pretty cool right off the bat. So now let's take a look at what's on the right side of your screen. What I have is a very simple Java application, and what it's doing is it's connecting to the failover group. So it's not connecting to a specific server, it's connecting actually to the listeners, right? So I have the primary connecting to the read write listener and the secondary connecting to the read-only listener. So that's one thing. And what we're trying to do is we're going to try to insert a row on the primary, and then we're going to try to read that same row from the secondary and see kind of how it works. And again, we'll talk about some application best practices, but here another thing I've implemented is retry logic so that if something doesn't work, my app doesn't break, it's just this is going to fail, but it will continue to run. Okay, so now what I can do over here is I can actually get the status of a secondary server. So what you're seeing is I'm saying get Azure SQL Database Failover Group, the name of the failover group, the name of the server. So in this case, I'm grabbing the DR server. So that's just what I called the secondary server, and the replication role. And we can see it's in the secondary role or the read-only role. Now, what I can do is I can go ahead and initiate a failover. You do have the ability to do auto failovers here, but I'm just initiating a manual one for demo purposes. And now what we're going to see is I'm just saying switch, and then I'm saying which one I want to become the primary. So I want the DR server to go from being the secondary to the primary. And what you can see on the right, let me scroll so it's more in the middle of your screen, pretty amazing. We had one failed entry. So you see insert failed, read failed, but now it looks like we're kind of up and running already. And so that's pretty cool how quickly you can do that failover. And then I can check the status of the DR server, just like I did before, the replication role, and see that it is the primary once again. So it was the secondary, now it's the primary. So that means that I didn't have to change anything. The auto failover group switch the primary and the secondary in the back end for me. And since I'm just connecting to the listeners, I don't have to change anything. I don't go down. So that's pretty powerful. And additionally, I can fail back and see sort of the same thing again. Now, another thing that I like to call out about these auto failover groups, which I think is interesting, is how many read replicas do you think you would get with a business critical database in an auto failover group? This would have been a good question to be a knowledge check, actually. So if you think about it, with your primary in an auto failover group, for business critical, you have a read only and a read write. So that's one read only. Now, if you flip over to your secondary, it's still an always on availability group. So you do have technically a read write and a read only. But for the auto failover group, you can use the readable there as well as the primary that's being used as a readable for the auto failover group. So I think that works out to like 3 readable secondaries. Does that make sense, Bob?
Yeah, absolutely.
Awesome. Cool. So again, you can see we were able to fail back with just one failure. And this is another example of a lab that you can actually try yourself in the Microsoft Learning path or through GitHub. Now we're right at the top of the hour. We still have some exciting stuff to cover in the next hour, but I think maybe we'll take about a 5-minute break and see you back to talk more about things like availability and consistency, really cool topics like accelerated database recovery, and that exciting challenge I'm going to throw at Bob right at the end. So stay tuned. Welcome back. Before we get into the next section, we did have a good question we wanted to talk about. Chris Spear asks, can all of these failover options work with private link, given that some require traffic manager?
So Anna, with the power of technology, we were not 100% sure, but I looked up this answer. Yeah, this should be fine because private link is supported with load balancing and traffic manager uses load balancers. So yeah, we're pretty confident that that is going to work even in an availability zone where we use a traffic manager or whether you have to deploy your own. So pretty confident that that private link is going to work just fine.
Awesome, thanks. Now we're going to shift gears a little bit and we're going to talk about availability and consistency.
Yeah, Anna, as you've asked me and talked about with me a little bit about my career at Microsoft, certainly part of that's been in support. And one of some of those difficult cases that I would receive from customers dealt with these topics. So if you first just look at comparing SQL Server to Azure SQL, let's talk about availability first, just to make sure you understand what's possible, not possible. So first of all, in my career at Microsoft, I made a living of teaching people how to put a database in emergency mode, right, for disaster recovery purposes when they would start SQL Server and they could not access their database or take it offline and do some crazy stuff with copying files around, and you wouldn't believe the stuff we would do. So you can't do that with Azure, and for a very good reason. You don't need to do that. We have everything necessary behind the scenes to make sure you saw the built-in HADR things that we provide and the SLAs we provide. So we've not found a case where we actually even have to do this for you either. We could do this if we had to in an emergency type situation, but we don't really want to go down the path of giving you those options because guess what? You might be able to go do something that violates the SLA that we promised to give you. So in order to make sure we make that consistent, we don't do that. Now, you might need to do certain things that restrict access to a database. So we don't allow you to put database in single user mode, which is another reason why you can't do the first two, because you can't put a database in single user mode, but you can put it restricted user access allowed. So if you need that type of functionality, you can do that. And then Anna, when you're my age, you get to tell fun stories. So back in 2005, my colleague and I, Robert Dorr, pushed at that time the engineering team to give us what I call a backdoor. It's not a security thing. A backdoor to SQL Server if it was hung, like you couldn't get access because everybody's blocked or something. So we do have some health alerts in the case of Azure SQL to detect certain problems that we'd fail over. But in case that's not possible, the dedicated admin connection that you've used, or DAC, is allowed for Azure SQL Database and Managed Instance. So you could do a DAC connection to get into that backdoor to see if there's like a hung SQL Server. And then we're going to talk in the next slide about accelerated database recovery and that amazing story. And that's on by default. And it is important to be on default to ensure we meet those SLAs, but to give you the highest availability of your SQL Server at all times. Now, what about consistency? Again, I mean, Anna, in the day, I used to get up on stage at PASS and I used to corrupt databases with hex editors. Like I would go twiddle a database in a hex editor, and I would show you how to patch it or recover it, right? Now, why did I do that? So one reason I did it was to simulate a hardware problem. Like what if a database file got damaged from a hardware problem? Keep this in mind if you've looked at what we've talked about here. You always have multiple copies of your data and log files, no matter what you choose, no matter which deployment option you get. So giving you the given the likelihood of the fact that we've got this redundant copies of everything everywhere, what is the likelihood of multiple hardware failures across multiple things? Now, granted, if it's systemic, like a bug with SQL Server, bug with a hardware firmware layer or something, maybe that would be the case, but we haven't found that to be prevalent. And your backups, remember, separate storage, geo-redundant. So if I told you that I gave you by default, let's say general purpose, I gave you 3 mirrored copies of your database and log across 3 different storage systems, actual hardware storage systems, and 3 different copies of your backups in different storage systems separately from that, what is the likelihood that you're going to have a damaged database from a hardware problem? I mean, we reduce that probability just by that first statement alone. Now, we have some users that want to run CheckDB, and we allow that. You can run CheckDB to look at the consistency, which is more now the logical consistency sometimes of your database. And you can do that with CheckDB even in Azure Database, but we don't allow repair options because, again, we might be heading down that path of violating like an SLA type contract that we have. We use database checksum by default, and it's a very, very good reason we do that, because if we do detect that there's a problem, we can automate things behind the scenes. For example, and I remember when I was telling this story, we were talking about BC. And I said, oh, wow, Anna, we've got availability groups. We probably can just use automated page repair online if we need to. And you're like, say what? And I'm like, hey, in availability groups, because we have those replicas, if we detect a page is damaged, SQL Server can automatically go grab a good page of that same database and online just restore that page back to the primary. And we do kick that in if we think it's necessary. It's all online. You may not even know that happens. We have a lot of integrity alerts in our system, and we do some repairs without notification to a customer if we think there is no impact to you. But if we think there is, we will proactively notify a individual customer to say, hey, for example, in this particular situation, we found a problem. We may need to restore your database for you and get you back up and running to minimize downtime, minimize data loss. So we have a lot of things we've done. We talked about backup integrity. But one thing that we add is SQL Server has the ability to look at lost write and stale page detection at a hardware level. And we can do that. And if we detect those kind of problems, we can initiate some automatic repair capabilities. So I guess I would summarize by saying that I spent a lifetime of repairing people and patching people. And we kind of believe in the Azure environment, we've put all the necessary things in place so that this doesn't become an issue anymore. Pretty bold statement, right?
Pretty bold. One technology that I know you've harped on a lot and that I'm always still learning more about is this idea of accelerated database recovery. Can we do as we would say, a double click into that?
Well, we're hyper-focused here on this boot camp, so yes. So Anna, let me paint a story for you over the career at Microsoft of a case that a customer would call in. So let's say that Buck Woody, got onto this primary server and he initiated in a transaction a delete of 1 million rows, okay? So this comes along, right? Buck initiates this. Doesn't know what he's doing, typical Buck. Somebody asked to know if I knew Buck. Well, there you go. Buck's going to do that. Now, Irish, she's a pretty smart person. She's been in SQL a long time. She comes along and says, I got this covered. I'm going to kill Buck. Kill his transaction, kill his session. She wants to kill Buck, but she kills his session. So goes along and kills his session. And all of a sudden now, and Buck look at their computer and it's in a rollback state. And they're like, what the heck are we going to do? So they call Bob. I'm in support. Bob, we're in a rollback state. I'm like, yeah, what'd you do? Well, Buck did a transaction. He deleted 1 million rows. Sorry, Buck did this. Reset. I tried to kill him. I'm in a session and I did this. And then now it's in a rollback state. How long is this going to take? And I said, as long as it takes to roll back that transaction. And they're like, this isn't acceptable. And they hang up on the phone on me. I'm like, man, okay, well, sorry. Got to be consistent here. So Anna, you're a pretty smart person. You come along and you've researched on the internet that you have the answer to Rhea and Buck. You walk up to their desk and say, hey, I got this solution here. What we're going to do is we're going to kill SQL Server. We're just going to crash the process because I've heard that when SQL comes up, it just recovers the database just like that. So you initiate a kill of the whole SQL process before Rhea and Buck can say anything to you because you're smart and you've read on the internet. That's the way to solve this. And SQL Server comes right back up. And in the error log, it says recovery 1%, 2%. So you, Buck, and Rhea are looking at this error log as it's just like a modem, ka-chunk, ka-chunk, ka-chunk. And then you call me and say, hey, we're sorry, we kind of cut you off, but Anna went ahead and killed SQL Server. And I say what? Why would she do that? They're like, well, she heard it's going to be faster. And then, but now we're seeing that it's even slower because it's going to this recovery thing and it's this percentage of 1, 2, 3. How long is it going to take, Bob? And I say, well, as long as it takes to run recovery and roll back that delete. Because as it turns out, Buck was, deleting like bank records or something, right? So we need to bring those back in the fold so we don't have bank records that are lost, right? So, Rhea is looking at this and says, Bob, there's got to be a better way. And so future Bob comes into place, right? And says, yes, I Bob, back in the day, says future Bob has the answer. And future Bob has the answer for something called accelerated database recovery. So if you look at this technology, this is something we were actually born into the cloud to make sure we can deliver, on these SLAs. So let's just kind of take a look a little bit about this. So we use a persistent version store for ADR. This, by the way, works, Anna, in SQL 19 as well. Although you need to turn it on there, it's not on by default. We use it by default in Azure. Persistent version store is a little bit like the version store in TempDB. What we're doing is we're keeping versions of changes in the database. And it's independent of locking and isolation levels. So for example, if you're using snapshot isolation, we're going to use the version in the version store we're keeping, but we still support read committed because the versions are more around not isolation levels, but around keeping changes so that things like rollback can be as fast as a snap of your finger, or undo recovery. Remember the 1%, 2%, that kind of thing. It happens so fast in many cases that the status, we don't even print that out because it just shows up. And the other cool part of the story, because Elaine Dormal, he's another part of your ragtag team of administrators, he's complaining this whole time because he can't truncate the transaction log and it's growing out of control. So he came into that foray and said, what are you guys doing? I cannot truncate the transaction log. We're going to run out of disk space. That's because active transactions keep that from being truncated, not with ADR. Active transactions don't hold up log truncation with ADR because we have versions in the database. Now, get a lot of questions about this stuff, like how fast is it? Does it require more space? Do I see versions in TempDB? Does it work with availability groups? The answer is yes. But here, I love the cop-out I made in this scenario. Here's what I did. I just point people to the white paper. Why would I do that? The engineering team that wrote the code and built the technology built a white paper called Constant Time Recovery, which was the initial version of this project. And they describe everything. They give experimentation results of how much space it takes. Does it affect performance? Does it work with secondaries? How does all that work? What you can expect from using the technology? And they were awarded the ability to present this paper last year at the VLDB conference last August. So it is, to me, groundbreaking, innovative technologies. I show it off all the time with SQL Server. In our workshops at ak.ms SQL workshops in the SQL 19 section, I have a lab where you can go through yourself and try and see how amazing this technology is. So Anna, the good news is that you, Buck, Ree, and Elaine, your jobs will be saved by this technology, and you don't have to call me anymore because this just works. So.
That's awesome. Thanks, Bob. Now, we've talked about a lot of capabilities, and really now that you understand the capabilities, it's going to be turned to you now. You need to make the right choices for your organization, for your scenario, depending on the requirements that you have, whether it's around long-term backups, whether it's around RTO and RPO, if you're going to be geo-distributed and how, if you need things like availability zones to get that extra level of SLA, or even if you need read replicas. We talked about a lot of different options, whether it's geo replication, business critical, auto failover groups, even how you can kind of combine these to get more readable secondaries. Even Hyperscale gives you up to 4 readable secondaries. But really, you got to answer some of these questions and decide what's the right level of availability for you to be at. Also there's this really important bit, and I've touched on it just briefly in some of the demos, and it's about your application. Is your application ready? Bob, do you have some tips on how people can, prepare their applications to be connected to Azure SQL?
Absolutely. So first of all, if you just think about some of the standard deployment options that we have, forget the fact you're using geo anything. Failover can occur for various reasons. And so in our discussions with customers, a lot of times they have not built their applications to retry logic to connect when a failover happens. And so in Azure SQL, though, it can be slightly a little different. One thing I even have observed is that, remember our architecture of gateways and then deployments of nodes? Again, the gateway being a set of computers, actually, right, of nodes that you connect into and it redirects you. So imagine a scenario where the gateways are fine, but you're failing over, or you have a problem with a node failing over in general purpose to a secondary node. And at that point in time, your app gets disconnected. Well, in a normal SQL Server environment, you're just going to get like a network failure, right? And apps have seen those kind of type problems before, and they reconnect actually based on that logic. We in Azure can detect that the gateways are fine, but we know that the nodes are down or are failing over, and we actually give a different error message. So you need to take a look at it. We have some guidance in our documentation about how you would make your app more resilient in an Azure environment, and you're going to like it because it's going to be a lot more logical for you in that case I just talked about gateways. But you think about the geo scenarios, using the load balancers or traffic manager type technologies is really important because it helps abstract what you're doing, or in the case of auto failover group, ensuring that you're connecting to the failover group. Because Anna, I don't know if you know this or not, but in the demo you did, you still can connect to the individual servers of the failover group directly. So I've seen people make that mistake that they set up this auto failover group and then they connect to the individual servers, and then a failover occurs, and now they're not talking to the primary anymore. So take advantage of the fact that when you do an auto failover group, you're pointing to the right failover group server or the listener. So that's just a few thoughts that I have.
Thanks, Bob. While we're here, and I know we passed it a little bit, but there are a few questions about ADR, if you're down to try to take a few of them.
Of course. I love talking about
that. The first one from Amina is, how does the transaction log behave in ADR if everything for point-in-time restore is not there?
Right. So, Amina, remember, we're using a full recovery database in Azure. So we're backing up the transaction log. So while log truncation is not beholden to active transactions, transactions are in logging for full recovery is being backed up in our log backup. So we still can do ADR and we still can do point-in-time restore because we're using full recovery and because we're backing up the transaction log. I think that's where they were heading with that question.
I think so too.
Yeah.
We have one more question and then we'll move on to monitoring. But Avi asked, is the PVS like keeping a log of changed pages as done with differential backup?
Great question, Avi. In the white paper, you can see the details of the architecture. What we really do here is we keep two types of versions at the row level. So it's all at the row level. So changes are made to rows, inserts, deletes, updates, and so forth. So we'll keep those changes either in row within our row structure of a page, or in some cases, depending on the size of the change, we have something called an off row version store, which is a system table that records information chaining back to the row itself. And we're pretty smart about this. We can decide to clean up versions that we don't need in line. So it's running a command. We can say, oh, we don't need this version anymore. We'll just clean and merge back the row to their original state, or clean up that off-row version store. So I think you'll love, if you like to geek out, look at the white paper because they have diagrams and they talk about the internal row structures of how we implement that technology.
Awesome. Now, we've configured, we've learned about the capabilities, we've done all this. Now, how are we going to keep track of how this is doing?
Yeah, I just love the fact that when we thought about what we're doing, we wanted to make sure everybody get a picture of monitoring things. So if you talk about availability, what are you monitoring? And if you think about the objects involved, you're monitoring databases, like are they available? You're monitoring backup restore histories. You're monitoring the status of your replicas. You may want to find out why you had a failover occur. You might want to monitor the availability of your instance of your server. But have you ever thought about monitoring the region or data center availability? Because remember, you're deploying within our ecosystem and our regions. So what I love about this solution here for all these types of things is we give you all sorts of options, both from an Azure interface point of view, from a SQL Server point of view, through like T-SQL and so forth, and from a CLI point of view. So if you kind of look at the gamut of all the tools we provide, it can contain everything from a service health dashboard to monitor data center availability. So we actually have a dashboard that says, what is the availability of just Azure SQL services in the East US? Or is the entire East US region down, for example? So you can monitor and detect and be alerted to our data centers down, right? Or the overall service of Azure available in a given place. You can also use even Azure services to monitor things like the health of your database deployment, right? Like resource health. Those are the resource health area in the portal and through CLI to see maybe I failed over. Maybe it was an automatic failover occurred because of an incident that happened. So you can do that to go look at things like failover reasons. And you can even do log analytics. Because of the fact that we put things in Azure, the ecosystem itself, you have Azure Monitor and Log Analytics to look at about anything you can think of in terms of service health or resource health. Remember, let's keep in mind the two differences here. Service health is not your database or your server or your deployment. That's the overall product that we're providing in Azure or a data center. Whereas resource health, by its name, is specific to the health of your database, your instance, or your deployment. So what about T-SQL? Well, you can use Xevent. Great technology we talked about yesterday. But guess what? Let's say backup history is something you want to look at. In managed instance, you can use an Xevent to go trace and see what is the history of all those automated backups you're doing. And for things like long-term retention backups, we provide interfaces in the portal or through CLIs or even through, the Azure portal to go look and see what is the history of those long-term backups. Now, restore is an interesting one that people have asked me about, restore history. Like, how do you track that? And if you remember what we've talked about, a restore is a deployment of a new thing, right? So in essence, it's a deployment tracking now. So the activity log, for example, could be used to go look at the history of a restore scenario because it is a deployment in the Azure ecosystem. And remember, we said deployments are tracked in things like Azure Monitor or in the Azure Resource Manager with activity logs. But for example, replica status is interesting. We still have catalog views and DMVs, and I can use a DMV to go look at the status of my replicas in, say, a business critical deployment, or I can look at the status of even geo-replicated scenarios, like we talked about geo-replication, through a series of T-SQL DMVs. So we give you the gamut of Azure interfaces through the portal, through things like Azure Service Health and Dashboard to, again, look at the product perspective, resource health through CLIs or through the portal, look at your resource, T-SQL commands to monitor various aspects of availability, and then CLIs. You always want to be able to do CLIs. Just keep in mind the CLIs tie into the left because those are just command line interfaces that are all using REST APIs behind the scene. Now, our colleague Uber Essen works on our team to support and to help lead our management pack story. So you'd be happy to know that for System Center folks, we have management packs for both Azure SQL Database and Managed Instance to help you monitor your Azure deployments through the System Center SCOM operation system. So in my opinion, it's actually a pretty good wealth story here of things we're giving folks, both from Azure interfaces and through T-SQL.
Yeah, definitely. I think you're right on the money, Bob, and I appreciate all the details that you shared with everyone. In the labs, they'll actually get a chance to see some of these things, like using log analytics, taking a look at the service health. So hopefully that'll be good for them as well. Now let's take a look at a knowledge check. So we have two questions. One of these you might find tricky, but let's give it a try anyways. So the first is, what methods can you use to monitor region and data center availability? And the second question is, which of the following is not a way you can monitor instance, server, and database availability? So two questions. Go ahead and put your answers in the chat.
Yeah, this is a little tricky, actually. This will be interesting to see what people say. And I, of course, am doing my Sherlock Holmes deduction method here to look at these questions, because I have to admit, I'm not sure I've seen these questions. So, okay. But what do we got? What do we got out there?
Yeah, so we just have a few answers coming in now. It looks, for the first one, we're split between D and A. D and A,
okay.
And the second one, we're getting mostly A. Some B's, but mostly A.
Some B's. Okay. All right. Okay. Still coming in, or you want to take? You mean to take a shot at these?
Yeah. Why don't you go ahead and take a shot at it?
Okay. So remember what we said about region and data centers. That's not specific to your resource. That's like the overall Azure product, right? What Microsoft is providing. So the Azure status dashboard is something that, certainly applies there. And I did mention, I didn't really dive into it, but I did mention you can get alerts from that to be alerted whether there is a problem. Like, for example, if I put a lot of things in East US and I need a text message to say East US is down, I need a geo restore to go take place, you can do that. So actually, you can do status, alerts, and so D probably is the right answer.
Right. And I think for this second one, which is interesting, seems like maybe people used your method of
and I love the way that you did not emphasize the not.
I tried really hard. I think I smiled.
Yeah. So let's talk about the true part of it, right? Since we're doing the not part. So resource health is a way to monitor instance, server, and database because those are resources, right? And because you can do it in the portal, you have CLI options to do that. So C and D would apply. So if we're doing the not case, A has to be the answer, right?
That's correct. Yeah.
Okay. Yeah. Because remember, Azure Service Health is not your resource. Now, here's the tricky part of the question. If the service isn't working, you probably can't get access to your resources. So in a way, implicitly, it's a way that you potentially, but if that's not always the case, there actually technically could be a service health issue in Azure where your resources are still available, but for example, there's something else going on that we can't do for you as part of your database or deployment. Does that make sense? You might be able to connect to it and query on it, but maybe event threat protection is not working or something like that. So keep that in mind, that service health is important to look at because it could dictate the capability of something, but you still can get access to your data.
Awesome. And someone commented that they missed the not. So I did a good job. So
yes, I would never miss that though.
Never.
That's never happened.
So as we wrap up this module, we're not done. We still have more. So don't drop off yet. We have more. You're not going to want to miss it. I'm going to put Bob on the spot. He doesn't know that yet. But if we look at what we've done so far today, we talked about the built-in availability story, including read replicas. We think it's a really powerful story. A lot of the things that were really complicated, stressful, time-consuming, worrisome to set up and monitor on-prem can now become much easier and make your lives easier, so you're not having to call Bob in the middle of the night like Ree and Buck and myself and Elaine ultimately ended up having to do. Additionally, we talked about how you can go further with some options like multi-AZ deployments or zone redundancy. And we talked about how you can do things with geo replication or auto failover groups, some of the trade-offs there as well. And Bob talked about the many different ways and the many different things that you can monitor as far as Azure goes and the service, and then your instance and databases as well.
Yeah, and again, as we talked about this, the built-in availability story, the built-in disaster recovery story of Azure SQL, to me is one of the true hero capabilities. And if people look at what we provided, what we talked about, and if you don't even have that today in your data center and you tried to go do that, it's time consuming, it's costly, it's expensive, it's hard to do, takes a lot of expertise. And even though in our environment, you still have to monitor these things, we think we've got a really great story for what we call built in to the service. So great module, great job there. I think we should move on though and kind of cap today to put it all together. And Anna, let me start and then let you chime in. But as we were putting this together with the meat and potatoes, right? Remember, what is SQL? Deploy, configure, then meat and potatoes. Security, performance, availability. You were like, well, does it end there? I mean, do we just stop at that point? Like, isn't there a way to help the community as they're getting this training, wrap this in a bow, kind of put it all together? And so I was like, okay, Anna, what do you got in mind? And you're like, well, I think there's some scenarios, customer business scenarios we could look at that we could kind of challenge people with. And so, I said, all right, well, take a shot and tell me what, show me what you got, right? And you're like, yeah, I'll take a shot, but I'm not going to show you what I got. And I'm like, all right, fine. So yeah, why don't you talk to them about that?
Yeah, sure. So we have two scenarios and, we're really excited about this, or I'm really excited about this because I think this is a great way for everyone that's watching this now, live, later, to really get involved and kind of let us know what you think. And you'll notice for each scenario, we have a hashtag. So whether it's on LinkedIn or Twitter, if you just use that hashtag, we'll go look tomorrow. And we're actually going to provide our email address so you can, if you have what you think is a really good solution, you can send it to us and it might get featured tomorrow when we kind of discuss the solutions. Now, this first scenario that I came up with is about a global CDN or global content delivery network system. And you can see they have a few requirements that they want addressed. And so the idea is that you would come up with some sort of solution, some details around how they might implement this, maybe an architecture diagram, maybe some considerations or decision points. And, I thought it would be great to start by, asking Bob, how would you analyze this scenario? What
do you mean, like right now?
Yeah, like right now.
Yeah, you said you had something going on live YouTube. Thanks a lot, Anna. Is there a hashtag for I need to talk to Anna later? No, seriously, I love this because we've approached everything so far from a capability and a task perspective and so forth. But the real world, you got to put something together, right? Based on a business solution. So can I get any hints?
Sure. I can give you some hints. I actually went ahead.
There's a lot of words to read here, and
It is. And we even have some comments like that. And so I can give you some hints. I highlighted some things.
Oh, okay. Because I was reading I had a couple other things in mind I saw, but so across the globe, that's very helpful, right? Because that's one of the powers of Azure. We have geo solutions we just told you. So one of those geo solutions has got to be part of it. And even though you probably could actually implement managed instances or databases yourself across regions, you have to stitch that together somehow. So, but our geo options might be helpful there. You called out thousands of writes per second. That can mean a lot of different things, a lot of different people, but it does speak to probably some heavy transaction load thing. You know, latency could be something, right? If I looked at that. Now, CLR, I did look at that word, and we talked about surface area. And remember, that's kind of a SQL instance surface area thing. So whatever you pick has got to support that, right? And well, actually, I see now you say SQL surface area in the next sentence right there. Scale where they live. Yeah. So okay, so you need one of our solutions that support read scale probably, right? And maybe it's, you talked about across the globe, so I've got to be able to do scaling and read scale probably in different regions across the globe. I have to figure out, though, I guess part of the solution whether that's okay, depending on how I'm setting it up. In the second paragraph, which authentication? A hybrid environment. Yeah, okay, because I saw SSMS there, and then I see legacy application. Okay, so wait a minute. So an application on a non-Azure machine, a legacy app on a non-Azure machine. So I got on-premises to think about. And in the legacy app, I got to use SQL auth. And remember, we support mixed, we force mixed mode, right? So that's not a problem here. Although I have to think about in terms of the geo thing, how does that going to work out? Eliminating hard coding passwords and secrets is as possible. Well, the only way to do that is, some sort of integrated security, solution, which we talked about in the module was Azure Active Directory. So you're going to have to set up an Azure Active Directory system, but you're not going to be able to. And of course, in SSMS, you can use that one, right? So SSMS, you could use Azure Active Directory with MFA, for example. You even I think you showed that one. But for the legacy one, you'll probably have to just keep the SQL auth part. So what you're going to have to do, now that I look at this, though, Anna, you're going to have to create probably, like let's say using Azure SQL Database, for example. You're going to have to, you probably want to create contained database users that are based on passwords, and then contained database users that are based on AAD, which you can do that. And then, the legacy app could use the contained database users with the password, and SSMS users and the new apps could use AAD. I think that would work. Something like that.
All right, I'm going to stop you there. That's enough hints. You're doing pretty good, though.
Okay, well, hey, put me on. I mean, right?
Yeah.
Okay.
No.
Way too many answers. Is that what you're saying?
Well, no, you gave some great pointers on what our viewers should think about when they go about building their solution. But I think there are a few things people might decide to do a little bit differently. So I'm really excited to see what you guys come up with. Remember, just use that hashtag, and we'll be sure to look at them before tomorrow.
Also, is it hashtag I'm better than Bob, or is that one of those you're going to throw in there as well? Or?
You can add Anna. That was awesome.
Anna, that was awesome. Okay, that's
or hyper focusedness. I'll take those.
Focusedness. So this says one. Do you have another? Crud, you got another one. How many are we doing of these?
Just two.
Okay.
So we have another situation. This one is about a mission critical application. It has a different hashtag, Azure SQL Critical 1. And Bob, I'm going to go ahead and give you a few tips.
To cut it short, I got it.
You're not so on the spot having to read 2 paragraphs.
Oh, it must be good. Okay. So I mean, I'll just use your hints for a second, right?
Okay.
To shorten the time. I don't know how much time you have here, but I mean, I'm glad. I mean, that actually stood out for me. Those numbers stood out, right? So, and I really specifically covered SLAs, and so people could go back and look at the slide deck. Which, Anna, I think the slide deck is on GitHub, right?
That's correct. The slides are in GitHub.
So ak.ms/SQL workshops. So you go there and you get our workshop and the deck's there. So, but you can even look that up in Azure SLA. I'll give folks a hint. Go look at the Azure SQL SLA, and this is listed. And so you have to pick a solution that matches that, right? If you have to have that requirement. So that's number one out of the gate. You just got to pick that. I won't tell you what it is. I know what it is, but you got to do it. So data sovereignty. This is interesting because it does call out where you deploy. So you're going to have to pick a region or data center potentially that deals with that. And that may be, this is interesting because it'd be interesting what customers come up with to say, like, I would love people that are non-US customers on our broadcast to tell us what region you would pick based on the sovereignty maybe of your needs of your country. So below, DBAs must not be able to see sensitive data. There is a specific feature to help that. and it's in SQL Server, so that's something there. Troubleshoot performance using the portal. DBAs need to be able to troubleshoot performance using the portal. So you just get that, right? The portal gives you ability to go look at things. I think it'd be interesting for people to tell us, based on what they've learned, what can you see and what can you not see there, actually. And there might be an access thing, because you said DBAs with that, and then SSMS ADS, and then create new container-based users who must be mapped to AAD. Yeah, we specifically talked about that in our security module yesterday. So if you have to do that, so that's interesting though, because that may only be available in a particular deployment option. You'll have to go back and double check that one. So that would be my thoughts.
Yeah, I think those are great tips, great pointers to help our users. Bob, do you think this is going to be useful for people to go through and send to us?
I think so, and here's why. Because in the real world, somebody's going to ask you, "Hey, can Azure SQL meet the needs of our business?" And you're an expert, or you're trying to become an expert, and they're not going to say to somebody, "Hey, by the way, I need this technology." A lot of cases, right? They're going to just give you a business requirement, and some of that was technical, right? Because they were putting in tools and so forth. So it's going to be this combination. But yeah, how else do you apply what we've talked about without looking at an actual business problem? Even some technical requirements, and then kind of mapping that together to lay out a complete solution. So what I love people to do in the homework, tell us your deployment option and why, but tell us what capabilities you need to light up and how you would do it to go meet the needs of that thing, right?
Yeah, no, I think that's a great comment. And as we go forward and look about what's happening tomorrow and what we would love for you to do between today and tomorrow is, review these modules. If you haven't had the chance to review the earlier modules, you can do that as well. What I have up here is just an example, again, of what this Azure SQL Fundamentals on Microsoft Learn looks like. This is an example of the backup restore unit. You can see there's lots of exercises from point-in-time restore to some exercises around high availability and auto failover groups. You can go try this for free using the sandbox provided by Microsoft Learn. Back in the learning path, we have all of these other modules, which some of you might have already completed, including the putting it all together. So this is where you can go in and you can see those scenarios again, and maybe get a few tips for what you'll do in the solution. There's no complete solution there, but you can maybe get a few tips there.
So you're saying that I could have gone to this before all of this. Yeah, thanks a lot.
Yes,
you're
welcome.
That was awesome. Sure.
But now you know, and it wouldn't have been as fun if you weren't on the spot.
Yeah, that's true. Honestly, I'm really being serious. I would love people to say, "Hey, Bob had some really interesting ideas, but this is a better solution than what he was talking about." And again, I didn't tell you the exact answer. I kind of gave some answers I think that probably apply. But yeah, it'd be kind of cool to see. And I even noticed that you gave your email address for people to send you something. What if somebody actually gave you a diagram or something? That'd be kind of cool.
Yeah, I would love. I'm like really excited and really hoping you guys.
Are you gonna put those answers on the air tomorrow?
Yeah, I plan to. If we get some good solutions, I plan to put them up and we can kind of talk about them and see see what you guys come up with.
Would love to do that.
And so tomorrow we'll be back here at the same place at the same time. We're going to do things that are a little bit different. We're going to really spend some time talking through how you might go about picking the answers to these solutions. We've got some knowledge checks around it. We're going to put up your solutions that you guys submit to us. And then we're going to do something interesting. We're going to do an Ask Me Anything to kind of round it out. We've covered a whole bunch of content, so we plan to spend some time. You can ask about Azure SQL, but you do have Bob Ward here, so I'm sure we'll get some great hyper-focusedness questions that we can answer there as well. And then finally, I'll say, if you enjoyed this or didn't enjoy this or have feedback on this session, please let us know at aka.ms/feedback2020. That really helps us decide, should we do more things like this? If so, what should we do differently? What should we do the same? We just really appreciate it. It just takes a few seconds to fill out the feedback form for today. And tomorrow's our last day. So if you've been attending with us, you're about 3/4 of the way through the boot camp. So you can give yourself a little pat on the back for that as well.
Hey, and I'd like to comment in that tomorrow is really important because as you had the idea of the scenarios, we wanted our community to understand that Azure SQL is SQL Server in the cloud, right? With these different ways of integrating things. But we wanted you to leave with knowledge that you can go further. I mean, this is once you start working in the cloud infrastructure, you're open to all these ideas. So I hope tomorrow you come back, because we want you to have that feeling of, yeah, it is SQL Server. I've seen the differences. I see all that stuff. But what can I do different? What can I do new? And I think, Anna, there's probably even, I can't help myself. There's probably even a slide on, what else should I know or something like that. I have to, put those little thorough details in there. I think we have some of that maybe.
Yeah, definitely. That's a great call out. We're going to go deep into some of the things that didn't quite fit into a specific module. And you'll see a little deep dive on things like errors and how those are different as you move to Azure SQL. As we close out today, I want to thank you all again for joining us. We really appreciate your joining us in these busy times and these crazy times of wherever you are in the world. We hope this is useful. Again, please fill out the feedback, and we'll see you tomorrow.